We Go Innovate. In collaboration with GAST, Ghana STEM Network, GH Scientific and Exploratory presents GH for STEM Juniors Challenge. From Navrongo to Bolgatanga, from Boku to Paga, young scientists from the Upper East region of Ghana joined the GH for STEM Juniors Challenge to perform fascinating science experiments using local materials they can find. This should be fun! GH for STEM Juniors Challenge. Samuel Deira is a junior scientist in the Upper East region of Ghana. He's a student of St. James RC JHS located in Kajaro. He converts electrical energy into sound energy for his experiment. For this, he needs a magnet, a solenoid, a non-magnetic container, a battery, and an amplifier. This surely will be an interesting science practical. Energy can be changed from one form to another. A magnet is found in many of our home appliances, such as sound systems, some doors, and cabinets. A force around the magnet is a magnetic field, which can produce electricity.
I'll start by coiling my solenoid on the container.
A solenoid is a wire coiled around the magnet to create the magnetic field.
So I'm leaving the first end of the solenoid to serve as a terminal. And you mount them to the container, and also you leave the other end of the solenoid to serve as another terminal. So now I'm testing my solenoid to see whether the terminals are okay. I see sparks, which means my solenoid is okay.
With the spark, we can confirm that electricity is running through the wire.
So now I'm testing it in the magnet to see whether the electromagnetic force has been induced into the solenoid. In my first test, it attracted because they are unlike poles. And the second test, it repelled because they are like poles.
Like poles repel, and unlike poles attract.
So now I'm connecting my solenoid to the amplifier to test. The solenoid is fed by electrical energy from the amplifier. So now I've connected it to the amplifier, and the solenoid is containing electrical energy because it serves as an inductor.
A conductor allows electrical energy to pass through it.
So now I'll open my magnet. The noise is as a result of the electrical energy stored in the solenoid that is converted into sound energy in the magnetic field.
The electrical energy in the magnet pushes the air inside the container up and down to produce sound.
The experiment is used in the application of electrical doorbells, speakers, alarm systems. My name is Peter Kututra, science teacher of St. James RC Junior High School, Kajolo.
Most homes are equipped with doorbells, which uses this principle to produce sound when pressed. Samuel was great at showing us how to produce sound energy from electrical energy. How about you? Can you try this experiment at home, either by yourself or with your friends from school? Also, make a video or take pictures of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Deira Samuel. I school at St. James RC Junior High, Form 2. Kindly vote for the experiment converting electrical energy to sound energy using magnetic field.
Now that was an exciting experiment, wasn't it? Vote for Samuel Daire of St. James RC JHS in the Upper East region of Ghana at www.wegoinnovates.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. Emmanuel Swansea is a junior scientist in Balopia JHS in Navrongo. Emmanuel's school is located in the Upper East region of Ghana. For his experiment, Emmanuel will design a periscope. For this science practical, he will use a box, a pair of scissors, a pencil, a rule, 2 mirrors, and a protractor. Now let's see what this junior scientist can do. A periscope is an instrument for observation. It obeys the principle of the reflection of light. Reflection of light sends back light rays which falls on the surface of objects.
Measure 7 centimeters, then you move forward and measure 7 centimeters 4 times. So then you measure the height of the box, 75 centimeters.
The longer your box, the further you'll be able to see with your periscope.
We measured 45 degrees angles at each end size of the box.
The angle of incidence must be equal to the angle of reflection.
So first of all, place the viewpoint of the mirror to match the 45 degrees angle at the end.
Mirrors will produce image by reflection.
Now use the other cut part to cover the half of the periscope. This is a periscope I constructed, and to prove it work, I'm going to view this object by looking at the other side of the periscope.
Periscope is an instrument which is used to view hidden objects in position. And we have the viewing side and then we have the object side. So you are going to look through the viewing side, which there will be a reflection from the object side. My name is Martin Abavre, science teacher in Balobia Junior High in the Upper East region, Navrongo.
Submarines use periscopes to see what's happening on the surface of water while they are underwater. What do you think of Emmanuel's experiment? Cool, right? So now, you should try this at home, either by yourself or with your friends from school. Also, make a video or take pictures of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Anzi Emmanuel. I school at Balobia Junior High School, a Form 3 student. Kindly vote for my experiment periscope in this Juneos challenge.
Now that was an awesome experiment. Now vote Emmanuel Swansea, Balopia JHS, Upper East region of Ghana. at www.wegoinnovate.org. You can vote as many times as you want. It's free. G8 for STEM Juniors Challenge. Meet Saka Ibrahim from Bolgatanga Preparatory JHS, located in the Upper East region of Ghana. He uses an empty box, a cylindrical tube, and a black polythene rubber to design a pinhole camera. Now let's see what this junior scientist can do. A pinhole camera is used to view objects as well as take pictures. It has a tiny hole but doesn't have a lens. A lens is used in modern cameras.
Let's take your empty box. Draw two diagonals crossing each other. With the aid of the pair of a divider, I perforate a hole on the point of intersection. Just a small hole, not making it big, in order to prevent light.
The hole is made very small to give a clearer and exact image of the object.
Then I come to the other side of my box. I take the cylindrical tube, then place one side on the middle of the box. Then get an outline of the cylindrical tube on the box. Then I cut the outline. Take my plain sheet. Then I cut it round. Then I pick my cylindrical tube and place the plain sheet on top. Then I try to fold the plain sheet on the cylindrical tube. Then I mend it round. Then I pick my cooking oil and rub it on the plain sheet in order for it to be translucent.
The oil makes the paper translucent for the object to be viewed to show the image quite clearly.
To make my cylindrical tube dark, I'll cut my rubber. Then I wrap it over the cylindrical tube.
The inner part is made darker so as to absorb light onto the part of the translucent paper where the image of the object will be focused.
Then I pick my box again. In order to make the inner part darker, I'll cut my rubber and wrap it, leaving the two holes open. Now I'll finish covering my box with the black polythene rubber. Partially fix it back to the hole created. In order to make the translucent material positioned, push it gently. Truly it works, but in order to see how the pinhole camera works, I would like to light a candle. I view again.
This pinhole camera today have helped in modern cameras because they use the principles and they have modernized how the pinhole camera works. My name is Gabriel Tobuga, a science teacher of Paga Preparatory JSS.
The pinhole camera is used in situations where there is no lens available and it produces images. Now that was an amazing experiment, wasn't it? Can you try this experiment at home, either by yourself or with your friends from school? Also, make a video or take pictures of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Saka Ibrahim from Bolgatanga Preparatory Junior High School. I appeal to all Ghanaians to vote for my experiment on how to construct the pinhole camera using simple materials. Thank you.
Now, Saka's experiment was exciting, wasn't it? Now vote Saka Ibrahim, Bolgatanga Preparatory JHS, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. Coming from the Upper East Region of Ghana is Abigail Asumpaga. Abigail is a student at Grace Valley Academy in Bolgatanga. This junior scientist will show us the effect of atmospheric pressure with the use of an empty can, a tripod stand, a burner, tongs, and a bucket of water. Now this should be an interesting experiment to observe. The air in the atmosphere puts pressure on all bodies. This is atmospheric pressure.
First, you take your empty can, then fill it with water.
The can is filled with water in order to get rid of the air in it. The can was not empty initially because air had occupied it.
Then you put the can with water on burner. Then you wait till vapor comes out.
The vapor from the boiling water will push the air out of the can completely. The can will be left with water vapor only.
Now you see that vapor is coming from the container with water. Then you pick your tongs. Then you capsize it in the bucket full of water.
Inserting the can into the bucket of water will cool the can and cause the water vapor to condense. This is because the pressure outside the can is greater than the pressure inside.
The siphon uses atmospheric pressure in transferring liquids from a high level to a lower level. The pump also uses atmospheric pressure when trying to inflate a deflated tire. Strings that are used in the hospitals also uses atmospheric pressure. My name is Apela Samuel Azore, a science teacher of Grace Valley Academy.
Also, when you cover your saucepan when cooking or boiling something, the boiling occurs faster. This is why syringes are able to suck and inject liquids for several purposes. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid up the syringe. So now you've seen the effects of atmospheric pressure. Can you repeat this experiment at home? You can try it by yourself or with your friends from school. Also, make a video or take pictures of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Asunkalka Abigail. I am a Year 2 student of Grace Valley Academy. Kindly vote for me on my experiment, atmospheric pressure.
Let's support Abigail by recognizing her good work. Vote Abigail Asumpaga, Grace Valley Academy, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. We have junior scientist Fortunatus Ejaba Techi. He constructs a mowing machine. Fortunatus is a student of Moonlight International School, located in the Upper East Region of Ghana. For this experiment, Fortunatus needs a cutout milk tin, cells, a piece of wood, a motor, a switch, blades, and a disc. Now let's see what this junior scientist can do. A machine makes work easier and faster. For a machine to work, current must flow from the battery to cause it to turn. A mowing machine is used for weeding or for clearing weedy or bushy areas. It works faster and easier than a hoe or a cutlass.
First, I cut out a piece of plastic. I pierce a hole through the plastic using a divider. And then I begin the process of mending the blades onto the disc. First, I pour some small glue on the disc, put the blade on it. I put some ash to make sure that it sticks properly. I take the milk tin and I cut a strip off. I perforate holes in the strip of the milk tin. And then I attach the motor to the piece of wood using the cut-out milk tin. So I'm using this plastic as a stopper to prevent my disc from touching the motor. I turn it, making sure that the blades are not on top of the CD but rather beneath it.
Now the wires are connected to the wood to prevent the wires from touching the disc so that the blade do not cut them.
I turn the machine, I take my cells and I mend them to the stick with the help of my sellotape. I connect my wires to my switch.
Fortunatus must connect the wire to the battery and other components for the current to flow from the battery.
I turn on my switch.
The switch will turn the machine on or off.
And there you can see the machine is completed and is ready for use.
The related area in sciences and the machines. My name is Chaporo Yebeje Samson, science teacher of Moonlight International School.
This is a useful machine to have at home. You can try this experiment at home by yourself or with your friends from school. Also, make a video or take pictures of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Fortunatus Ajeba Ateji from Moonlight International School Year 3. Kindly vote for my experiment on how to create a mowing machine.
Now that was a useful experiment, wasn't it? Do you think Fortunatus deserves your vote? Now vote for Fortunatus Ajeba Ateji, Moonlight International School, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. Abdullah Salim is a student at Presby JHS in Navrongo, located in the Upper East region of Ghana. For his experiment on the application of electronics, Abdullah will use phone cells or batteries, a cushion, a milk tin, tires from bottle tops, cables, a motor, and a switch. Now let's see what this junior scientist can do. For substances to move, force must be applied.
First, I will get my milk tin. Then I'll now put the motor inside. After that, I'll get this tiny white thing. I will now place it with the back tire, which will connect to the motor with the back tire. Then I'll take my other 2 wheels, pick a piece of metal, join them together. Then I'll now take my cushion, design the body of the car. Then I'll now place it on top.
You can use any other lightweight material which can be shaped into a body of a car.
I'll be needing 4 nails, which will help it get attached to the metal without it removing. I'll connect both wires with the battery with the help of my sellotape.
Current will flow from the battery to the wire to make the car move.
Connect it with both battery and the motor. So I'll secure the wires with the help of the sellotape again. Then I'll take my battery, nail it here, put the second nail. Then after that is done, I will try the car to see whether the car will move or not. The positive wire of the motor is connected to the negative side of the battery. The negative part of the wire of the motor is connected to the positive side of the battery. This shows that the rotation moves backwards.
The ability of the car to move involves a motor, which is changing the electrical energy supplied by the cell, the drive cell, the battery, onto a mechanical energy. I'm Adiga Emmanuel Dijera, and this is Presbyterian Junior High School, Navrongo.
Energy in the battery can be converted to other forms of energy by the motor or light, like we see in bulbs and LEDs. This is why battery is needed to start a car, since the energy is converted from electrical to mechanical energy to move the car. Without the battery, the car will not move. To confirm that, replace the milk tin with Milo tin and repeat Salim's beautiful and interesting experiment at home, either by yourself or with your friends from school. Also, make a video or take pictures of your experiment.
Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Abdullah Salim. I attend Presby Junior High School. I am informed to kindly vote for my demonstration, the reverse GR car.
Did you enjoy Abdullah's experiment? Vote Abdullah Salim, Presby JHS Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Junior Challenge. Atamya Makrina is a student of Sacred Heart International School located in the Upper East Region of Ghana. Today, she'll show us how a capacitor charges and discharges electrical energy. She does so by utilizing improvised circuit board, some wires, a cell, a switch, a resistor, an LED, and a capacitor. Now let's observe her in scientific action. A capacitor stores current. Our home appliances, such as ceiling fans, contain capacitors for the storage of current needed for it to work.
I'll start by connecting the wires through the improvised board. connect the electrical components, I'll first of all begin with the switch.
The switch opens and closes the circuit. This is what turns electrical appliances on or off.
Next, I'll be connecting the resistor.
The resistor reduces the flow of current.
My next step will be for me to connect the LED. I'll then be connecting the capacitor, a cell.
The capacitor will store the electric charges.
For the capacitor to charge, I need to put on the switch.
The switch closes the circuit and allows the electricity to flow. A circuit is a combination of electronic components for the flow of current.
The LED will come on once and off.
LED is a light emitting diode. It produces light when current passes through it.
Now to discharge the current in the capacitor, I'll take off the battery. Join the wires of the battery together. I'll then change the terminals of the capacitor.
The application of this experiment is seen in computers, televisions, and that of radios. Capacitors are used in computers to store electrical energy or electrical current and gives it to the computers when necessary. My name is Apale Godfred. I teach integrated science at Sacred Heart International JHS.
So now you see how a capacitor charges and discharges electrical energy. Cool, right? Try this yourself at home or with your friends from school. Also, make a video or take pictures of your experiment.
Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Atamia Makrina. I attend Sacred Heart International School. I'm in Form 2. Kindly vote for my experiment on how the capacitor charges and discharges electrical current.
Atamia's experiment was interesting, wasn't it? Vote for Atamia Makrina of Sacred Heart International School, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. Aisha Mohammed Nana is a junior scientist from St. John Bosco JHS, located in Navrongo in the Upper East Region of Ghana. Aisha uses potassium permanganate crystals, a thermometer, a Bunsen burner, some water, and a glass beaker to show how temperature affects the rate of diffusion in liquids. Time now to observe her experiment. Substances move from where they are concentrated.
To begin with, we first fill our glass beaker with water. So our water is 50 ml. Now we'll place it on a tripod stand for the water to heat.
The levels of water are the same in both beakers. The water is the medium for diffusion. The temperature of the water is being raised by applying heat.
It looks like our water is warm enough. The temperature of the warm water is 72 degrees Celsius. The temperature of the room temperature water is 30 degrees Celsius, which means there's vast difference in the temperature of the room temperature water and that of the warm water.
The applied heat increased the temperature of the water, making it warm.
I drop 2 potassium permanganate crystal at the same time into both beakers and observe what happens.
It is important to drop the potassium permanganate in the 2 beakers at the same time, since time affects the rate of diffusion.
It will be observed that the particles of the potassium permanganate in the warm water diffuses at a faster rate than that of the cold water.
The water molecules in the heated water moves faster because of the extra energy they have gained from heating. They then carry the particles of the potassium permanganate away as they move faster.
Putting a tea bag in warm water diffuses at a faster rate in the warm water than in ordinary water. Also, placing food coloring in warm liquids diffuses faster than placing it in ordinary water. I'm Anya Beatrice, the science teacher at St. John Bosco's Junior High School.
So now we know how temperature affects the rate of diffusion in liquids. You should try this at home, either by yourself or with your friends from school. Also, make a video or take pictures of your experiment.
Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
I'm Asadu Rebeba via Rosalind.
And I'm Mohammed Nanaisha.
And we are the young scientists of St. John Bosco's Junior High.
Kindly vote for our experiment, which is on the effects of temperature in diffusion.
Aisha's experiment was amazing, wasn't it? Let's show her our appreciation. Vote for Aisha Mohammed Nana from St. John Bosco JHS, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. Hilda Awuni is a student of St. John's JHS located in Bolgatanga within the Upper East region of Ghana. She'll show us how to prepare hydrogen gas. She does this using diluted hydrochloric acid, a funnel, a magnesium ribbon, a matchstick, and a test tube with its holder. Now let's see what this junior scientist can do. Hydrogen gas is used in many industries, especially petroleum industries.
First of all, I would have to wear my goggles in order to prevent the acid from splashing into my eye.
Strong acids are corrosive and can cause damage to any part of the human body.
Then pour the acid into the beaker gently. I would go on to pour the acid into the test tube with the help of the funnel. I would peel the coating of the magnesium ribbon in order for it to react faster with the hydrochloric acid with the help of the knife. I would cut a piece of the magnesium ribbon and drop it into the hydrochloric acid.
Acids produce gas when a piece of metal drops into them. Magnesium ribbon is a metal. The gas released is hydrogen gas.
I would use the lid to cork the top of it. The bubbles indicate that the hydrochloric acid is reacting with the magnesium we bond to produce hydrogen gas. I would go on to light the match and take it closer to the reaction. When hydrogen gas comes into contact with a lighted match, it produces a pop sound.
Hydrogen gas produces a pop sound in the presence of fire.
The application of the experiment is the hydrogen gas that is generated can be used to fuel rocket, which is used for space operation. It can also be used to fly hot balloons. And then we also get ammonia from hydrogen gas, which is used to prepare fertilizer for agricultural purpose. My name is Paga Anaba, integrated science teacher at St. John's Junior High School, Bolgatanga.
What do you think of Hilda's experiment? Cool, right? So now, you should try this at home, either by yourself or with your friends from school. Also, make a video or take pictures of your experiment.
Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
My name is Awini Hilda, a Year 3 student of St. John's Junior High School. Kindly vote for my experiment on how to prepare hydrogen gas.
Now that was an awesome experiment, wasn't it? Let's support Hilda by recognizing her good work. Vote Hilda Awoni, St. John's JHS, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. From the Upper East Region of Ghana, we have Belinda Bedway. Belinda is a student at St. Teresa's JHS. Belinda uses the kapok fruit to make some organic soap. Now let's see what this junior scientist can do with only one very versatile fruit item. Soap is used in our homes for bathing and washing purposes. Soaps are made from fats and oils that react with a base.
This is the kapok fruit. It has 3 main components at the pod: the seeds and the wool. My experiment is about using the alkaline, which is obtained from the pod, and the oil, which is obtained from the seeds, to make organic soap.
The pod is burned into ashes, which is used for the soap preparation.
So this is the wool I've gotten from my kapok fruit, and I'm using it as a filter paper. Then you now place it over your beaker and add your ash. You slowly add water to the sizes. So we have to wait for a while so that the filtrate can be able to get out. So we are now at the point of evaporating our alkaline solution.
This is done to separate the water, which will evaporate from solid crystals of the alkaline, which will be left behind.
This is a sample of my alkaline crystals. If you are measuring 2.5 milliliters of the oil, you have to measure 3 times of the alkaline crystal to be able to dissolve in the oil. I pour my crystals into the evaporating dish. I add water.
This is done to get a pure alkaline solution.
So I slowly dissolve it. So I measure 2.5 of the oil into my evaporating dish.
Palm oil, cottonseed oil, olive, castor, coconut oil, and so on can also be used.
I wait for some time for the oil to be able to boil before I now add my alkaline solution. So I start to make sure that it is evenly mixed with the oil.
The foaming indicates that soap is formed from the mixture.
There's a foam forming on the surface of it, so this tells you that it is really a soap. I'm going to remove it from the fire to ensure that it doesn't burn. To ensure that my mixture is really a soap, I need to test to find out. So I add water. So if I shake the bottle vigorously, you will see foams inside it. So the scientific concepts here are saponification. This is the reaction between fatty acid and alkaline to form soap and glycerol.
The lesson can be gotten from acid, base, and salt. They can use the baobab fruit to also produce the same material. I'm Sonwacho Prosper Ajawake, science teacher from St. Elizabeth Junior High School.
This principle is used in the production of local soaps. Can you imagine making soap from fruit? How awesome is that? Try this experiment at home, either by yourself or with your friend from school.
Make a video or take some pictures of the results of your experiment. Ask your teacher or your parents to help you post the results of your experiment on social media. Tag We Go Innovate so that you can win some fabulous prizes. Don't forget to add your name and the name of your school to your entry and hashtag GH4STEM. Good luck with your experiment. You can be a junior scientist too.
I would like you to kindly vote for my experiment of making organic soap from the kapok fruit. I'm Badwe Belinda, attending St. Teresa Junior High School in Paga.
Now that was a useful experiment, wasn't it? Do you think Belinda deserves your vote? Vote for Belinda Bedway, St. Teresa's JHS, Upper East Region of Ghana at www.wegoinnovate.org. You can vote as many times as you want. It's free. GH for STEM Juniors Challenge. At the heart of GH for STEM Juniors Challenge are these teachers who, against all odds, are creating powerful learning environments using everyday materials as teaching aids, even in fairly complex scientific experiments.
GH for STEM.
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 GH for STEM Juniors Challenge. Don't forget to vote for your favorite experiment or demonstration at www.wegoinnovate.org. Find the region or name of the school, the name of the junior scientist, and vote. Remember, you can vote as many times as you want. It's free. Now, guess what, friends? The Juniors Challenge isn't over. Next week, we've got some young and clever scientists from the Brongahafo region of Ghana. They'll be demonstrating some of the most innovative experiments. Don't miss out. GH for STEM Juniors Challenge.